Greetings, grade 11. So we've decided to mix things up a little bit, and instead of giving you your usual voice note lessons, we thought that we'd try something a little bit different, and I would record the lesson in the form of a YouTube video. We're going to begin these YouTube videos this week by having a look at fluvial systems. Now this word, fluvial, is simply a fancy word for rivers. So we're going to be learning about rivers. With section A, the first part of the notes that you were given last week, we will be looking at the different parts of a drainage basin. Now these are just simply the very basic terminology that we use when talking about rivers. I think every single one of these terms you would have heard of and you will remember from grade 9. So let's begin our revision of these terms. Well, we're at the beginning, so it makes sense for us to talk about the source of the river. If you can just excuse that slide, I don't know what happened as I moved this from my iPad onto my computer as a PowerPoint. Somehow it seemed to cause, I see the words, to mix into each other. So please just bear with me. All right, so the source of the river is the point where the river begins to flow, which is always in the mountains. So whether there is possibly a spring where water that is underground flows out onto the Earth's surface, or possibly water that accumulates from rain and water that accumulates from meltwater when snow melts. This water, as you can see in those photographs, as it accumulates, it begins to run down the mountain as a very small stream. So the source, the beginning. From the source, we move to the mouth. The mouth is the end of the river as it flows into the ocean. Isn't that the most beautiful photograph you've ever seen? So the mouth is the end of the river as it flows into the ocean. At this point, I want to just highlight two terms that we will use all the time, upstream and downstream. When I talk about upstream of a river, I am saying that we are talking about the path of the river as that river moves towards its source. But when we talk about the downstream of the river, we are talking about the part of the river as we move towards the mouth. So upstream, think about up in the mountains towards the source, and downstream, going down the mountain towards the mouth. We all know what tributaries are. Tributaries are the smallest streams that join up to make the main river. I've just noticed now that my arrow has been slightly moved, unfortunately, but it should be pointing at one of the smallest streams. You will see how all the tributaries in this particular diagram join up, and they all accumulate to create the main river at the main canal. Here's actually quite an interesting computer-generated image. Here we see how all the smallest streams all join up, and as they join up, the rivers get bigger and they obviously carry more water, and all these tributaries join up to make the main river, which we can see on the bottom left-hand area of this slide. So your tributary are the small streams that join up to make the main river. The confluence is the joining of two streams. Now, I actually would like to show you that there are actually quite a few confluences in this particular diagram. If you have a look where my arrow is, that of course is showing a confluence. But notice over here, there is another confluence. If we move over here, you will notice that there, okay, it doesn't seem to want to make me to do it. There's another confluence over there. If we actually move over here, there's a major, I'm really struggling with this, aren't I? And if you come over there, there is another confluence. So the confluence is simply the point where two or more streams join or meet. The river basin, or the drainage basin, is the whole area that is drained by a river and its tributaries. Looking at the diagram that I have put on the slide in front of you, the river basin, or the drainage basin, is that whole area within the black circle. That whole area is drained by that river and all its little tributaries. If we look at this particular diagram over here, you will notice that the dotted line is the edge of the drainage basin. And all the land and the entire area within that dotted line makes up the drainage basin. It is drained by those tributaries and it is drained by that river. Notice, if you look, and let me actually once again show you. If you look over here, do you see there is the source? So that is where the river begins. And you will also notice that the source of the river is also the point where your tiniest tributaries begin to flow, joining up to make a bigger river. The river system is the network of streams that is created when all the tributaries and rivers join up together to create the network. So looking at the slide in front of you, every single river, every single stream you can see joins up, and together they create the river system or the river network. The watershed is a high-lying area that separates one drainage basin from the other. Have a look at this rather beautiful slide. Have a look at that full moon. Isn't that pretty? Anyway, you'll notice that my arrow at the top is pointing to the mountain. That mountain is the watershed. Now look at the arrow that I created below that. And that arrow, if you look very carefully, is pointing to a river. So that is part of one drainage basin that we can see. Now on the other side of that mountain, there is another river system and therefore another drainage basin. So therefore, that mountain, that high-lying area, is separating the drainage basin that we can see from another drainage basin behind that mountain that we cannot see. So therefore, I repeat myself, the watershed is a high-lying area that separates one drainage basin from another. Here is a schematic diagram showing you exactly what I showed you in that photograph. The watershed, you can see, is the mountain. The river system the tributaries and the river that we see in that diagram is one drainage basin. Behind that mountain, there will be another river system making up another drainage basin. And therefore that mountain or that watershed has separated the drainage basin that we can see from the drainage basin that we cannot see on the other side. So grade 11, that brings us to the end of all the different parts of a drainage basin. Very easy and certainly something I'm sure you can remember from grade 9. We're now moving on to the second part of your notes, section B. We're now going to do a more in-depth study of the fluvial system. In other words, we're going to do an in-depth study of rivers. We need to begin by understanding what the crust water is. When it rains, and that rainwater lands on the Earth's surface, it therefore enters the drainage basin. Now this rainwater can move through that drainage basin in two ways. Firstly, that water can move from one part of the drainage basin to another by flowing on top of the Earth's surface. So that water can either flow in the form of a sheet or a big body of water flowing down the hill, or it could flow in a river canal as a river. Either ways, that water is moving on top of the Earth's surface where we can see it, and we refer to that as runoff. As water enters a drainage basin, it could also move from one part of the basin to the other in the form of infiltration. Now, infiltration occurs when water sinks underground. As the rainwater lands on top of the Earth's surface, it starts to move underground. It moves through the soil and it starts to move through the rocks that make up the Earth's crust. This water that sinks underground, this water that we refer to as infiltration, can also be known as groundwater or crust water, which makes sense. Groundwater, it is in the ground. It's under the Earth's surface. Crust water, well, it sits in the Earth's crust. When water flows underground, we obviously understand that that water is moving through the rocks. If this is able to happen, then we need to understand that the rocks are permeable. It is only permeable rocks that will allow water to infiltrate and to move through those rocks. Let's have a look at the diagram to the left. Looking at that diagram, cast your eyes first to the word permeable. This shows you what permeable rocks are. Permeable rocks are porous. They have pores, they have holes, they have canals through which the water can move. Looking to the very left of that diagram, you will see the word non-permeable. Now, non-permeable rocks, such as granite, for example, are non-porous. You can see that they do not have holes. They do not have canals. and therefore the water cannot move through those rocks. And therefore, in areas where there are non-permeable rocks, infiltration will not take place. Runoff will take place. The water will move on top of the Earth's surface because it cannot sink through non-permeable rocks. Now that we understand what infiltration means, and we understand that water can be found under the Earth's surface, we need to now focus our attention on the different groundwater zones. There are actually 3 different zones beneath the Earth's surface where we can find water, and 3 different zones through which this infiltration takes place. Let's begin with Zone 1. Zone 1 is known as the zone of non-saturation. This zone is found immediately below the surface of the Earth. It is a dry zone because as the water is infiltrating, it does not remain in this zone. It passes through it. That then takes us to the second zone. The second zone is known as the zone of intermittent saturation. Now, the water, as it is infiltrating and moving down lower, it percolates through the zone of intermittent saturation. What this means is as the water is moving through the second zone, some water will remain in this zone. So this zone can be very moist. I always like to ask you to visualize as if you are digging underground. If you've got a spade and you start digging the soil that makes up the zone of non-saturation. It's dry. But as you dig deeper, you will reach the second zone and you will notice that the soil has become a lot more moist. The third zone is known as the zone of permanent saturation. This area is wet because this is the area where the groundwater or where the crust water accumulates. This is the reason when you would like to sink a well or a borehole, you would actually drill down into the zone of saturation. You would actually drill down into the third zone because that is where you're going to be able to find the crust water, and that is where you will be able to pump up the water onto the Earth's surface. I would like us to please go back to the previous diagram. And I actually see that I can't do that. Right, I'm learning as I'm going. Okay, let's remain looking at this diagram. It's absolutely fine. Can you see that label, water table? Now that is a very important concept. The water table is the zone that separates the second zone, the zone of intermittent saturation, from the third zone, the zone of saturation. So the water table is actually the surface of the zone of permanent saturation. It's almost like if you take a glass and you fill the glass with water, the surface of the water in the glass would be your water table. It's very important to understand that the water table fluctuates. This means that the water table varies up, higher, and down, lower, below the Earth's surface. depending upon how much rain has taken place. I really like this diagram because I think that this shows very clearly to you what I'm trying to say. Look at diagram A at the top. It's quite evident that there hasn't been very much rain. It's been dry. And as a result of this, the water table lies much lower and far below the surface of the earth. However, looking at diagram B, there clearly has been more rainfall. This, of course, has led to more water infiltrating under the Earth's surface. And this, of course, has caused the water table to rise up higher, almost like you take your glass of water and fill it up. And, of course, looking at diagram C with even more rain and even more infiltration, so we see that the water table has risen up even higher. So the water table fluctuates and varies. Now this is a very important diagram, and it's actually one when we get back to school and I revise this with you again, I'm going to actually get you to sketch this into your books. This diagram shows the seasonal variation of the water table. It shows how the water table fluctuates depending upon the season. Let's have a look at the diagram, the part of the diagram to the left. Now that diagram is showing the water table in the dry season, when there has been less rain. So because there hasn't been much rain, water has not infiltrated underground. And this has caused the water table to sink down lower. Looking, therefore, at this diagram, let me see if I can do this. I'm not very good at this. You will actually notice over here, can you see, the water table is actually below the surface of the earth. The riverbed is dry. That river has no water in it whatsoever. There's been no rain, and the water table is so far below the surface of the earth that there is no water from underground going into that river canal. That riverbed remains dry. Let's look at the part of the diagram to the right. This depicts the water table in the wet season. So there's been lots of rain. As a result, a lot of water has infiltrated underground, if you like, filled the glass of water, causing the water table to rise up. Have a look over here. Here it is. It's gone way up there. So your zone of saturation, you will notice, has become much bigger. You will therefore be able to see that the water table has intersected with the surface of the earth. This causes a process that we call base flow. Base flow causes crust water to flow out onto the earth's surface. This, we can see, results in the river canal filling up. Not only has the rainwater filled up the river canal, but base flow has allowed crust water from underground to seep into the river canal. You will also notice that further up, higher up the land, a spring has occurred. The water table is so high that it creates a fountain or a spring, and that crust water has flowed out onto the earth's surface. Here's a very interesting slide, and I would like you to actually look very hard at it, examine it, and I want you to tell me, which province do you think this diagram depicts? All right, so let's have a look. Right, so the first dotted line, this one over here, right, this isn't working very well for me. This one over here, they tell us is the winter water table. Have a look. This water table in the winter side, in the winter time, has actually intersected with the Earth's surface, causing base flow. The river is full. Look at the second dotted line, this one over here. That's the summer water table. Now, can you see how this water table has dropped down low? It is now below the surface of the earth. What province do you think this is? If you say the Southwestern Cape, you're right. Remember, the Southwestern Cape experiences a Mediterranean climate. And remember, that is when they receive their rain in the winter time, causing the water table to rise up. They experience dry summers, resulting in the water table in the summertime to drop down low. Is an interesting word which I suppose is more relating to your matric syllabus, but let's get familiar with it now, shall we? Aquifer. An aquifer is rock that allows water to accumulate in it, and therefore rock that can behave as an aquifer would be permeable rock, which is porous and therefore absorbs water. Well, the good news is that's the end of this lesson. I hope that these slides have helped. I hope that you've enjoyed this a little bit more than the voice note lessons. And please, guys, send queries to your teachers at any point. Any questions that you have, you can obviously, the advantage of getting a link is that you can listen to this explanation a few times, listen to it, and make sure that your summary notes are making sense.